Frame buffer objects, also known as render targets, allow us to store rendering frames in addition to the default frames that display our OpenGL scenes. They can hold depth and stencil data and support all the same pixel formats as the default display. Frame buffer objects are useful for creating post-process effects, such as anti-aliasing, shadows, and bloom. They allow us to perform off-screen rendering and then apply the results to our scene. To create a frame buffer, we first call function GL_GenFrameBuffers. We pass in an amount of frame buffer IDs we want generated and a pointer to an array of integers to write the IDs to. To store color data for the FBO, we create a texture map. The texture map has an ID pointer for the GL_GenTextures function to know where to store the generated texture IDs. Width and height values specify the dimensions of the generated texture. The internal format specifies the number of color components the texture will have. The frame buffer format specifies the pixel format. So, for instance, a shadow map FBO will have an internal format of GL_red because it only needs one color component, and the pixel format would be GL_depth component. The texture data format specifies the data type of the underlying data, so whether it is unsigned byte, short, integer, or half float. The texture wrapping format specifies how the texture is applied outside of its normalized coordinate range 0 to 1. We make an FBO active by calling GL_BindFrameBuffer. We can then attach the texture to the frame buffer using GL_FrameBufferTexture2D. The attachment index specifies whether it is a color, stencil, or depth-based attachment point. You can attach up to 16 different color attachments, one stencil, and one depth buffer. GL_DrawBuffers specifies a list of color buffers to draw into. To set the internal storage format of the depth and stencil components, we use GL_RenderBufferStorage. We need to generate a render buffer ID and bind it before we do so. We then connect the render buffer to the current frame buffer by using GL_FrameBufferRenderBuffer and pass through its attachment type. The attachment type specifies the type of data that is being attached, so either GL_depth attachment, GL_stencil attachment, or a combination of the two. We can use GL_CheckFrameBufferStatus to check for any errors in the construction of the frame buffer. To copy a frame buffer, we use GL_BlitFrameBuffer. After attaching the buffers for reading and writing, we pass in the dimensions and the type of data we want to copy, so color, stencil, or depth. If you want to change the resolution of the frame buffer after it has been created, you just activate the texture in render buffers and set the dimensions as so. To clean up the frame buffer object after you are finished with it, you call GL_DeleteFrameBuffers, GL_DeleteTextures, and GL_DeleteRenderBuffers.